Welcome back. This is the third video in Lecture 8 in GRA 6036, and we are working with Project 10. And now we come all the way to exercise D, where we are to fit a linear regression model with wage as our dependent variable and an indicator of whether or not we are above 3 in looks or below or equal to 3 in looks as the independent variable. Okay, so well, I know that I sometimes refer to the independent variable as a covariate, so just be aware that when I use those two words I mean the same thing. Okay, so let's see. Well, this is exercise, so we're going to fit this linear regression model right here with y being the wage and x being this indicator right here. And fitting such a model means finding good estimates of these two unknown values, beta naught and beta 1. So to do that in R, we use the LM function, so the linear model, and recall that the syntax for this function is that if our model is y equals beta naught plus beta 1 times x plus noise, then the syntax here is y tilde x. So this, I mean, if y and x is our data, then we can fit this model. So that's the syntax, and here we'll use wage as our dependent variable, and we take wage from the beauty 2 dataset. So that is the dataset where we deleted this one observation with an outliingly high wage. So I mean, it doesn't. So I mean, if you use the beauty dataset instead, so where you have not deleted that observation, you'll get different numbers than I. So, but I'll use this dataset. Okay, so this is y, then tilde and beauty. So we are to use this indicator that we have right here. So we can just copy that indicator and well, plug it right in, I think. So let's see if that works. So we look at, I mean, that works because obviously the LM function reads an indicator like this, which are true false values as zeros and ones. So to be even, I mean, if we want to be more transparent, so to speak, we can make an x, which is this true false vector multiplied by 1, and then we'll have, then x will be zeros and ones. And then we could have used the LM function LM function and just inserted x here, and that will give us the same thing as we got here. So the numbers are the same. So when we fit this model, well, this is our estimate of beta 0, and this is our estimate of beta 1. So now we are to make two new objects in R, beta 0 hat, and this object is supposed to be the estimate. So to get the estimate, well, so what we haven't done, I mean, a nice thing to do is that when we fit a linear model, we can make a LM object where we insert all the information contained in fitting this model. So you can call it whatever you want. I usually call it fit1 to indicate that it's the first model I fit to these data. So let's run this, and then fit1 is an LM object, so we can have a look at this object, and you'll get even more information out of this object if you do summary fit1. Then you get the estimates, the standard errors, the t-values, and the p-values, and so on. and also the R squared and things some things we cover in lectures, some things we have yet to cover in lectures, and some things that we will not cover in the lectures. Okay. So if you write fit1 $sign QF, then this will give you a vector with the two estimates. Now to pick out the first estimate, you can do the square bracket thing and write 1 for the first, so that's the estimate of beta. This is the estimate of beta 0, and then this is the estimate of beta 1. And actually, even though they have these headings, these are read as numeric objects in R, so you can do math with them. I mean, so even though it has this heading, you can multiply it by 10, say, and you get the beta 1 coefficient multiplied by 10. So which admittedly looks a bit strange, but is fully possible. So I mean, if you want to get rid of that heading, you could do there's a function called as numeric. So if you copy this thing into the as numeric function, you only get a number, which is more neat, I think. But that's do whatever you like. So now do this, and then beta, then this, and then these are our two objects, and so we have our estimates saved as objects, so we can play around with them later, and that's what we'll do in exercise E. So this is exercise E. Now we are to compute the predicted wage based on, well, the model we just fit to the data. So usually we would do, we would make an object called y hat, and then the predicted values is with estimates inserted and then multiplied by the covariates. So, this will give us the fitted values. But in this case, since the covariate only takes two values, y hat will also only take two values. So doing this and getting a big vector of numbers like this is a bit redundant, because I mean there are only two different numbers in this vector. Something you could see by doing unique y hat, which will return the unique values. So the unique function is nice. I mean, so if you have to illustrate it, let's say you have a vector A with 1, 1, 2, 2, 3, 3, and you then do unique A, then you get 1, 2, 3. Okay, so now we understand what the unique function is doing. So, but okay, in any case, to find the predicted values, since there are only two different predicted values, this multiplied by 1 and this multiplied by 0, we could simply do this. Now, so we see that the predicted, so this is then the predicted wage for looks both 3, while this is the predicted wage for those with looks less than or equal to 3. Okay, and now in exercise, so now we are to show that these predictions equals the average wage of people of the two groups. So I mean, we already computed the average wage of the two groups. It's here, so we can copy it, take it down here, and then this first one here should be equal to this one, which is false because of some rounding, but it's no big deal. So let's just, to be really clear, we can copy it like this, and then, well, these are the same numbers and these are the same numbers. So the reason for this returning false is because R is doing some rounding in the background in different ways that is not visible when it prints to this terminal. Okay, but they are the same numbers, and we know from theory that we'll soon go through that they should be the same numbers. So, well, they are the same numbers. Okay, so that was exercise E, and in the next video I'll do some more exercises.